Salt. What is its action in the soil? What is it that you're working on? Plant. Yeah, so what is a chelator? Have you heard of a chelator? So chelators, it's almost like taking charcoal in your system where you've got something that binds onto, in this case, a chelator in this case is claw-like and it's binding onto trace elements. So it's locking up those trace minerals that the plant actually needs to function well and function healthily. A really fascinating thing about glyphosate is it doesn't function in sterile soils. So why would that be, do you think? Yeah. So the action is that the glyphosate binds onto the trace elements, so the plant can't function naturally and can't take up those elements that it uses for protection. It then causes a proliferation of those disease organisms that then take the plant down, and so we see that plant being annihilated. So what's really interesting is what's happening in the States is we've seen year on and year on and year on of the Roundup Readies and all sorts of things, lots and lots of use of glyphosate, is that it's caused a proliferation of the bad organisms in the soil, and now they have diseases such as take-all, which is a fungal disease that they have no control for anymore, and now yields in the States are falling steadily each year, and it's a consequence of the proliferation of disease organisms. Did you want to add something? Because you were talking about...
I'm Phil. I'm a plant pathologist, plant scientist, and now a biological farming consultant, or really a farm performance consultant is what I call myself nowadays. I help farmers make their farms work and grow grass mainly. I had a long career in ag and hort in Hawke's Bay, and we were using, in growing crops in particular, we were using increasing amounts of herbicides.
Take your volume up, Phil.
Come and step forward. No, you. You need to speak up.
Oh, I'll talk up. So we were using increasing amounts of herbicides to be able to grow our crops without weeds in them. And what I've started to learn in more recent years, maybe over the last 5 or 6 years, that some of the effects of some of the chemicals that we've been using are much more long term than we ever imagined. Glyphosate was a classic. I guess I'm old enough to be involved in farming when glyphosate first came onto the scene, and it was such a fantastic tool because you could take out your plants without doing any damage to the soil, and it was a herbicide that could kill any plant, except for a few. There's a few that it doesn't kill very well. Stinging nettles one, mallow's another one. But what we developed was systems for controlling weeds using glyphosate several times a year. To get into a new crop, you'd use glyphosate. A couple of weeks later you could cultivate, and a few days after that you could be planting seeds. And we figured, and it seemed apparent too, that you could do that quite safely without having any effect on the ability to grow your crops. What we're starting to notice now, and I think the first symposium that I read about was in Europe and about five or 6 years ago, where a lot of scientists were getting together and saying, we're seeing funny things happening on these soils where we've been using glyphosate for the last 20 years. We've got lack of some trace minerals in particular. And actually the first warning sign, I guess, that I didn't understand was about 15 years ago when I was doing some research on fungal diseases on roots of plants, and I was reading a paper by a scientist in France saying that if you put glyphosate on a soil, the germination of the seeds that you planted on that soil was reduced. And most of the science fraternities said, oh no, that she's done something wrong there, she's made a mistake with her experiment, because we know that that doesn't happen. But the evidence is now becoming increasingly compelling. As Nicole just said, in the corn belts in the States now, they're starting to have wilt diseases in corn that never existed before. And what is happening is that the glyphosate when you spray it on the leaf of a plant, it translocates really well through the plant and stops photosynthesis and the plant dies. When you put it on the soil surface, we always learnt that it was inactivated, but in actual fact it's a good plant killer, and it kills the bottom of our pyramid of animals in the soil, the algae. It kills them. It also is a good chelator, as Phyllis said. It's a phosphate compound, and it chelates minerals, and it chelates a whole bunch of trace elements that largely with our modern system of farming we've ignored those trace elements. Now we're starting to understand that those trace elements are essential, as are all the biology that are in the soil to make things happen, to make minerals available to the plants. So far from being the wonder chemical that we thought we had 30 years ago or so when we started using it, it turns out that it's actually doing some stuff to the soil that we don't really understand yet, and we don't really understand much at all about the biology in the soil. I can be quite confident in saying that because I spent 7 years studying one fungal pathogen on the roots of one plant, and I don't know much about that, let alone let alone what else is happening in the soil. So the story I'm telling, I guess, a bit of a ramble, but what I'm seeing now in Hawke's Bay, I've spent a lot of time looking at squash crops and trying to get the fruit of squash crops to last longer. And one of the worrying things I started seeing on those crops was the sandy corners of squash paddocks. Once the Hawke's Bay summer kicked in, those sandy corners, and there's a few paddocks just down the road here that I looked at not so long ago, the plants started wilting, and there was no real reason why those plants started wilting. But what we do understand now is that the glyphosate that we used to wipe out the weeds to get the crop established also wiped out some microorganisms. We don't really know what they are or what they do, but it wiped them out, and the pathogens can take over and invade the roots. We're quite good at the pathology part. We understand the pathogen that's causing the problem, but we don't understand why it's happening. What we do know now though, and we're looking at here, if you stop using the glyphosate, the soil's quite forgiving, and the biology comes back, and plant nutrition becomes normalised.